Chapter 4.6, Formalizing Relations and Functions. Your objective for this lesson is, number 1, to determine whether a relation is a function, and number 2, to find domain and range and use function notation. A relation is a pairing of numbers in one set, called the domain, with numbers in another set, called the range. The domain are the x values. The range are the y values, also known as the input and the output. X is the input, y is the output. Example 1, identifying functions using mapping diagrams. So we have two parts to this. We have A and B. What we want to do is identify the domain and range of each relation, and then we're going to represent it using a mapping diagram. And we have to answer the question, is the relation a function? So to identify the domain and range first, what we're going to do is I'm going to highlight the domain with blue, and then I'm going to go back and highlight the range with pink. The domain are the x coordinates of your point. So it's the first number in the point. The range are the y coordinates in the point. So it's the second number in the point. Now I want to go back, and instead of listing them the way we did, we're going to list them in two bubbles. The first one are going to be the domain, and I'm going to write it in blue. And then the second is going to be the range, and I'm going to write it in pink. Alright, the domain in numerical order is -2, 0, 4, and 5. The range in numerical order is 0.5, 2.5, which actually is used twice, but I'm only going to write it once, and then 6.5. Now that I have them in their bubbles, what I'm going to do is connect the domain that matches each range with a line. So from -2, I'm going to draw a line to 0.5. Then from 0 to 2.5, I'm going to draw another line. Then from 4 to 6.5, I'm going to draw another line. Finally, from 5 to 2.5, I'm going to draw another line. What you need to notice is that each line represents a point. -2, 0.5 is represented here. 4, 6.5 is represented here, and so on. That's the mapping diagram. So first I've got domain and range. Got that taken care of. Then I did the mapping diagram. Now I need to tell if the relation is a function. The way you do that is with a mapping diagram, you check your lines from your x coordinates. If each x coordinate only has one line coming from it, it is a function. The x's can only be used one time. Okay, B, we're going to do the same thing. Domain in blue, 6, 4, 6, and 5. Range in pink, 5, 3, 4, and 8. And then we're going to do our mapping diagram. Domain in blue and range in pink. Domain in numerical order is 4, 5, and 6. Range in numerical order is 3, 4, 5, and 8. Now draw the lines that represent points. So from 6 to 5, from 4 to 3, from 6 to 4, and from 5 to 8. You have your mapping diagram. Look at your x coordinates. There's only one line from there, one line from there, but two from here. Because there's two lines coming from this 6, this is not a function. Guided practice number 1. Identify the domain and range of each relation. Represent the relation with a mapping diagram. So I'm going to leave example 1 up there. I want you to pause the video, do these two parts of guided practice 1, and then resume the video when you're finished. Okay, so you should have your mapping diagram ready. And so there's two lines coming from 4.2, which means that A is not a function. And if you inspect B, there's only one line coming from each domain, so B is a function. Example 2, identifying a function using the vertical line test. Is the relation a function? Use the vertical line test. So what you're going to have to do for A is graph the 5 points they give you on the coordinate plane that I've given you on your outline, and then I'll show you how to use the vertical line test. So to graph -4, 2, we're going to go left 4 and up 2 and put a point. -3, 1, we're going to go left 3, up 1. 0, -2, we're going to go left 0, up or down 2. -4, -1, we're going to go left 4, down 1. And then 1, 2, we're going to go right 1, up 2. Now what I want you to do is take your pencil, your finger, or a ruler, and I want you to pass it across this graph. So I'm going to use this pink line as my vertical line, and I'm going to pass it across my graph. If at any point on the graph it touches more than one line or more than one point, this is not a function. So I'm going to leave it there so you notice that it touches this point and this point. That fails the vertical line test. This is not a function, and that's because you cannot have repeating x's in order for it to be a function. At these 2 points, the x coordinates are the same. They're both going to be -4. You didn't have to graph it to do this, because you can see that -4 is used twice for the x coordinates. But the vertical line test is very easy, so I needed to teach you how to do it. All right, B. I'm just going to graph this one for you. This is called a parabola. With a parabola, you'll notice something. I'm not going to tell you yet. I'm going to pass this vertical line across this graph. Whoops. And it looks like at here and here it may go a little bit vertical, but you got to be very careful with it and be very sure. So when I pass it across, you see how it's not actually vertical. It doesn't actually lay on top of my line on either side. The legs of a parabola here and here don't actually go vertical. They are very close to vertical, but they're not. So a parabola opening upwards or downwards is always a function. And a parabola is that U shape you see. This one is turned upside down, but it's still a parabola. Guided practice number 2 is the relation of functions. So I want you to graph the 5 points on the graph, use the vertical line test, and tell me if the relation is a function. Resume the video when you're finished. Okay, so I'm going to take my vertical line and I'm going to pass it across A. What I see is that at every point there's only one x coordinate, so A is a function. Okay, take the same vertical line and pass it across B. And at this point, there's 2 points that touch the vertical line, so this one is not a function. Example 3, evaluating a function. The function w of x, that's how you say that as w of x, meaning that you plug x in and you get w out, equals 250 times x, and it represents the number of words you can read in x minutes. How many words can you read in 8 minutes? If x is the number of minutes, then you're just going to replace your x with 8. You're going to do that on both sides. Now the left-hand side, you do not multiply and get 8w. This is function notation, which means when I plug 8 in for a x, I'm going to get out a number for w. And I forgot actually to plug in the 8 for the x, so it's going to be w of 8 equals 250, and instead of x you put an 8. Now you just evaluate it. So 250 times 8 is 2,000. So it's going to be 2,000 words in 8 minutes. Guided practice number 3. How many words can you read in 6 minutes? So I want you to do W of 6 equals 250 times 6. Pause the video and resume when you've got the answer. Okay, if you evaluate it for 6 minutes, you get 1,500 words. Example 4, finding the range of a function. If you're given the domain of a function and they ask you for the range, what you're going to do is replace the x values with each domain value they give you, and you're going to get out a different y value. Then you're going to place each y value that you got out in its own list. So if I plug in 1, so f of 1, that's going to be negative 1.5 times 1 plus 4. And that's going to give me 2.5. If I plug in 2, f of 2 is going to be negative 1.5 times 2 plus 4. So that's negative 3 plus 4, which is 1. If I plug in 3, that's going to be negative 1.5 times 3 plus 4, which is negative 4.5 plus 4, and that's going to be negative 0.5. And finally, if I plug in 4, I get negative 1.5 times 4 plus 4, which is going to be negative 6 plus 4, which is negative 2. So my range is, in numerical order, negative 2, negative 0.5, 1, and 2.5. Guided practice number 4. Pause the video, plug in each domain value in for x, and find your range, and resume the video when you're ready to check your answer. Alright, first you're going to do g of 1, and that's going to be 4 times 1 minus 12. Then you're going to do g of 3, which is 4 times 3 minus 12. Then you're going to do g of 5, which is 4 times 5 minus 12. And then you're going to do g of 7, which is 4 times 7 minus 12. Find all of those answers. 4 minus 12 is negative 8. 12 minus 12 is 0. 20 minus 12 is positive 8. And 28 minus 12 is 16. So my range in numerical order is negative 8, 0, 8, and 16. Okay, for this lesson, there are no guided questions. That is because you are going to take a quiz at the beginning of class tomorrow to evaluate your understanding. There's too much cheating going on when it comes to homework, so I'm going to check your outline, and then you're going to take the quiz, and your outline will be a 100, your quiz will be a separate grade, and then I'll average the two to go in for your homework grade.